In 2016, a little box of a satellite built by students and engineers at the University of Colorado Boulder will launch into space, with help from NASA and the U.S. Air Force. CIRES' National Snow and Ice Data Center has been instrumental in the collaborative effort to put up a radiometer to gather important weather and sea ice data.
Polar Cube is the satellite we're putting up to study the atmosphere and the sea ice. So it's an instrument that's the first of its kind. It is a scanning radiometer, meaning it's sweeping the entire Earth in low Earth orbit. Polar Cube, and what it means to NSIDC, is we've been collecting satellite data for years. This is our first chance to get our own satellite up with CET and Space Grant. So this is a true passive microwave satellite, full scanning satellite. It's going to be looking at the atmosphere, it looks at the ice, but it's small. It's about this big at launch, size of a loaf of bread.
CU-Boulder engineering students have been a key part of the effort to build CubeSat and also its ground station. Built cheaply from salvage, a decommissioned NOAA antenna, and an old trailer.
What makes this project pioneering is that this is the first time that we're taking technology that used to occupy large volumes and cost a lot, and shrinking that technology, putting it into a small volume, and doing it at a cost that is so little that we can afford to put up a fleet of perhaps 30 or 40 of these satellites. And we're doing it with the students. The students are doing the design and the build of the satellite. One of the problems with the cost of our weather forecasting systems is we only build one of them, launch it at a time, and typically it's the only one we have operating in space. It has to be extremely low risk because of that. We can't afford to lose it. And as a result of that, the costs are driven up tremendously. The Polar Cube project, and in particular the fleet that will follow it on, takes a different view of this. We're going to be putting up a lot of them, so many of them that if one or two fail, it's not a problem.
One thing that they can't do today because of these incredibly expensive satellites is we can't get the temporal resolution. In other words, we only get to see them once a day, once or whatever. We can now put up a series of these things and see things every 15 minutes. That's what this buys us.
The effort makes CU-Boulder part of an international trend favoring smaller, lower-cost satellites powerful enough to keep a close eye on the environmental changes, but cheap enough to launch regularly.
One of the huge benefits of this project is, currently, if you're not aware, it typically costs $500 million to $900 million to put up a satellite. We've built this entire satellite and now its ground station for less than $200,000. This is low-cost science, huge benefit for the public. If we can replicate this and start putting up satellites on a normal basis that can collect Earth-observing satellites to detect what's going on in the climate and what's going on in the Arctic in particular, and do it much cheaper, this is a huge benefit to society, and we still collect the information.